Assalamu alaikum, dear audience. Welcome to the presentation, salinity modeling and zoning map in the changing climate. So this is the content of the presentation, but I am not reading before you right now. So let's proceed. This is the objectives of the study. Characterization of existing salinity level in the river system and estuaries, preparation of scenarios considering climate change and human interventions, assessment of future salinity scenario and strategies for improvement. This is the river salinity dynamics. So the freshwater flow of Ganges, Jamuna and Upper Meghna river pushes the salinity downward, and tide from the sea actually pushes the salinity upward. So these two forces, freshwater flow and downstream tide, actually determine the salinity level in the complex river system of Bangladesh. Now, according to the salinity level, we divide the southwest and south central coastal region of Bangladesh into three regions. So the first region, the first one is Ganges dependent zone, which is highly saline. The Ganges dependent zone receives freshwater flow from Hista, Mathavanga, and Ichamuti river. And Hista, Mathavanga almost lose connection from Ganges river. So no freshwater flow is supplied. So hence the Ganges dependent area is highly saline. The next is Gorai dependent zone. Gorai dependent zone receives freshwater from Gorai river and from Arialkha river through Madaripur Bill route. This zone is less saline than Ganges dependent zone. Finally, the mixed zone, which receives freshwater from mainly from Arialkha river and Ilisha river, as this river connection with Podda is live, so the mixed zone is less saline. Now let's see the observed data. This is the observed data at Shiksha river. Maximum salinity at Shiksha river is 25 ppt, which is during April. And maximum salinity at Ruksha river is 18 ppt. Maximum salinity at Nabonga river is 8 ppt. And now we can see that salinity rise builds up from June and February. It reaches to maximum value during April. From May and June, salinity begins to drop and reaches to the lowest value during July and August. Now let's see the salinity at mixed zone, which is at Burishwar river and Tetulia river. And now we can observe that salinity level in these two rivers is below 1 ppt. So this is actually the freshwater zone of Bangladesh. Now this is the modeling framework, but I am not describing right now. So let's proceed. This is an animation of salinity intrusion along the coastal zone of Bangladesh. So we can see that the salinity isohaline actually moving with direction of tide. During high tide, the isohaline propagates upward, and low tide it propagates downward. Now this is the calibration plot of salinity. The calibration plot here is shown at Ruksha river and in Baleshwar river. The blue line is simulated salinity and the red dot is observed salinity. Now this is the scenario table that we devised. There are 4 scenarios, which is baseline scenario, Ganges barrage scenario, Gorai river restoration, and Indian river linking project. Under each scenario, there are 3 time frame which is present. That means year 2019. We choose year 2019 as a present scenario because our study actually started from 2019, and 2050 and 2100 is actually the projected scenario at climate change condition. In in projected period, we applied sea level rise, land subsidence, and transboundary flow change. The sea level rise and climate change information we obtained from climate change team, and land subsidence information is we obtained from land subsidence team, and we observed their presentation yesterday. Now, the transboundary flow change we obtained from climate change information and GBM basin model tool, and sea level rise projection we observed from climate change report. The sea level rise with respect to year 2019 at 2050 is 20 centimeter, and year 2100 is 92 centimeter. Now let's see how salinity intrusion will be in climate change condition. The red line is 1 ppt salinity line during April year 2019. Now it is the 1 ppt salinity line for 20 centimeter sea level rise at projected period year to 2050. So the salinity 1 ppt salinity line actually move upward by 12 kilometer along the Gorai River, and for year 2100 during this time the sea level rise will be 92 centimeter. For this period, the salinity will move upward by 16 kilometers along the Gorai River, and we see that our freshwater zone will be lost at year 2100. The 1 ppt salinity line will move upward by 66 kilometers along the Shahbazpur channel. Now we come to the interventions, how we can improve the scenario in to fight the climate change condition, what we have to do. So this is the proposed intervention. This is the Ganges barrage intervention. The Ganges barrage is proposed to construct at Rajbari, Pangsha, and the flow diversion is proposed at Hisna River, Gorai River, and Chandana River. The diversion strategy is shown here in graphical format. And let's see how thing will behave during climate change condition. As previous, the red line is 1 ppt salinity line during April, and the blue line is the sea level rise condition without intervention. And if we apply Ganges barrage condition with on 20 centimeters sea level rise, then we can see the salinity line, 1 ppt salinity line during April is moved downward by 56 kilometers along the Gorai River. Now we come to another interventions, which is the Gorai River restoration. Under the Gorai River restoration, the dredging of Gorai River is proposed at first 40 kilometers of stretch after the offtake. And this information I obtained from the IWM 2014 report, Gorai River restoration report. We see the red line is the flow hydrograph before dredging. Before dredging, the flow at Gorai is almost zero, and maximum salinity at Ruksha River is 16.8 ppt. After dredging, which is blue line, the flow hydrograph is blue line, which is flow of Gorai River after dredging. After Gorai River dredging, the flow is increased by 100 cubic, and the salinity at Ruksha River is decreased from 16.8 ppt to 7.3 ppt. And this is observed data, based on observed data. Now for simulation, like previous, this is 1 ppt salinity line, and this is for 20 centimeter sea level rise without intervention. And if Gorai River restoration is implemented in climate change condition, that means for 20 centimeter sea level rise condition, we see 33 kilometer downward movement of 1 ppt salinity line from the baseline. Now our final scenario is Indian River Linking Project. In short, the Indian River Linking Project is diversion of water from water surplus basin to water deficit areas where there is drought and scarcity of water. If Indian River Linking Project is implemented, the Ganges flow is observed, which is likely to be decreased by 19%. Annual average flow of Ganges River will likely be reduced by 19%, and for Brahmaputra River, the reduction is 4.1%, and it is the finding of IWM 2008 study. Now, what will be the scenario if the Indian River Linking Project will be implemented? We see this for, here I show this for projected period year 2100. So like before, the red line is 1 ppt salinity line for April, and the red line is 1 ppt salinity line for year 2100 for 92 centimeter sea level rise condition. And if the IRLP is implemented at year 2100, we see the 1 ppt salinity line will further go upward by 5 kilometers along the central coastal zone. So in summary, what is our findings? That for 92 centimeter sea level rise condition, the freshwater area, Potuakhali, Bhola, Borishal, Bogona district will completely will not be freshwater zone anymore. And Ganges barrage is more effective than Gorai restoration condition. And thank you.